Hey, hello everyone. Hope you all are able to see the screen. Let me also put a poll question here. Can you all please answer to the poll question? Wonderful. So we'll get started in the next 2 minutes. Mr. Srikanth, Mr. Srikanth Sinha, who is heading task, would be here shortly, and then we will get started. No, no, session is yet to start. In the next by 2:10, if Mr. Shrikant Sinha joins, then he's going to address the gathering, and then we can get started. If not, then I shall briefly introduce about the session, and then we can get started. No,
Yeah.
the session is yet to start. Yeah, good afternoon, everyone. We will get started. You must be seeing on my screen that I've mentioned we will start in the next 2 minutes for the last 10 minutes, right? But yeah, we shall get started by 2:10, please. All right, I think we should get started. Thank you, everyone, and welcome to the session. And I would like to, thank Telangana Association for Skill and Knowledge for giving us this opportunity to deliver machine learning on cloud and auto ML with a tinge of explainable AI. And I thank all the professors who have enrolled for the session. This is a proof that you all are keen in learning newer things. This is a proof that you want to upskill yourself on the latest of the happenings and then pass on this information to the fellow students, right? Uh, Thank you once again for enrolling for the session. You can either join using Webinar Jam, the link which has been SMS to you or sent over email. And it is also posted on the Telegram group which we have created. So these are the various forums through which you'll get access to this Hello. Friends, are you able to hear me now? Please, can you confirm? I'm talking. If you're able to hear me, please let me know. Okay. So you are able to hear me, right? I would once again end this poll and ask a poll question yet again. No audio because I stopped. I got a call and then I had to stop. So that's the reason why there was no audio. Okay, fine. So you are able to hear me. Uh, just give me a minute. There is some communication issue going on. Just a moment. One second. I'll be on mute for a quick 2 minutes, friends. Okay. So while Mr. Srikanth and Ms. Shiba from Task join, I would like to quickly introduce myself and quickly explain you about the course outline so that it motivates you all enough to, you know, stay there. Let me first log into my LinkedIn account. So this is me, friends, just in case you want to know who is the person who is training us. That's me. I'm Bharani Kumar Depuru. I'm an Industrial Revolution 4.0 implementer, chief data scientist and technology advisor for 4 different firms. I am an alumnus of Indian School of Business and a visiting faculty at Indian School of Business. Alongside that, I've done my master's from IIT. This is in short about my profile, and I also work with companies such as HSBC, ITC Infotech, Infosys, and Deloitte in the past. I worked on probably 60, 70 projects until now in the space of advanced analytics. And that's in short. And if you want to connect with me, sure, here is my profile. I shall share it with you all over the chat and feel free to connect with me. And if you have any further questions, certainly you can ask. Oh, why did this open up? I'm not sure. Okay, anyways. So that's in short, friends, about my profile without, you know, describing a lot about myself. And before we get started, let me tell you one thing. While Mr. Srikanth and Ms. Shiba join, let me tell you that machine learning on cloud is the next big revolution. And auto ML, the promise of auto ML as we see it today is that people need not know how to write even a single line of code. Even a single line of code, and trust me when I say that. We are going to practically do a hands-on and see how amazing this auto ML is. People need not know the math behind how algorithms work in the space of machine learning. How cool is that? And yet, implementing AI is the future. This is for 90% of the population of students who want to get into um, one second, huh? Guys, I'm a, a little bothered now. I wish to check one more poll here. Let me start the poll. Yes, friends. So once again, sorry for this. I just want to know how many of y'all are able to hear me and how many of y'all are not able to hear me. Okay, so I will confirm. All right, friends. So I believe 92% of the people are able to hear me. So this is in itself a proof that you are able to hear me because, you know, the other people weren't able to hear. Okay. Yeah, it gets duplicated when screen gets duplicated when you know, toggle between the different screens. Back to our discussion. So 90% of the people who want to venture into the stream of data science, they would go ahead and join industries, various organizations, companies as data scientists. Maybe they want to work with TCS, Infosys, Wipro, Microsoft, Google, whatnot. And they want to work as data scientists. And maybe 10% of them want to, you know, take the route of doing research or doing their PhDs or postdoctorates. People who want to get into this stream, do research and come up with a new algorithm altogether, work on new inventions as part of their PhD or postdoctorate. For these people, they need in-depth programming knowledge and in-depth math knowledge. For them, it's needed. But for those people who want to get into industries and start working in various companies, do you know what? Auto ML is the way to go. Why? I'll give you an explanation here. When you join, for example, say you joined TCS as a data scientist, TCS will be doing projects for various customers and say they are building a machine learning algorithm for ICICI Bank. And say this project is about loan default prediction. What do you mean by that? Who are the people who will take loan and do not repay the loan? Say that is this is a project which ICICI Bank has given to TCS. Now, what will a team in TCS do? The team in TCS will say, okay,
Hello.
Yes, Shiva, are you able to hear anything?
See, I'm not able to hear, and I've got messages from the faculty are also that they are not able to hear. I am able to see the screen that Bharani Kumar is sharing. I am able to see that screen.
Yeah, just now Bunny speaking. Just check once.
Yeah, I'm not able to hear, and some of our RMs have also joined from here in our office. They are also not able to hear.
Okay.
Can you please check the audio somewhere? I think there's something wrong somewhere. Even the faculty are not able to hear.
You're not able to hear you, sir.
And where is chat enabled? I'm not able to see the chat.
Okay. One second, please.
Um,
Hello. Yeah. So let me continue here. Miss Shiva, are you able to hear me now?
yes, I'm able to hear. Can
Wonderful.
you hear me?
The problem is when multiple organizers join with the same link, I will
Okay.
be thrown out of my previous,
Oh, is it?
login. That's
Mm-hmm.
the problem. Yeah, over to you, Miss Shiva and Mr. Srikanth, sir.
Uh, Sir, can you hear me? Shrikant sir, are you there? You're just wasting out of so much time for the faculty. Just give
Yeah,
me
yeah.
two
But
more
then
minutes.
I ensured that I continue with the session by introducing Task and
Okay.
Mr. Srikanth Sinha, so that these kind of glitches do not arrest our progress.
Mm-hmm.
Yeah. So I'll be
Okay, what I'll do is I'll pull in Shrikant Sinha on the last day of the training program.
sure.
Okay,
That would be better, Shiva. Yeah.
yeah. So
Thank you.
I would just give you a warm welcome to all the participants here. We've been trying a lot of program to do a lot of programs for the faculty, and 360-degree Innodatatics has come forward for this course, Machine Learning on Cloud, to the faculty members. Thanks to the team of Innodatatics. And I just want to tell all the faculty that it takes in a lot of effort for us, like the partners and for us, to do such kind of programs. So please do attend these programs religiously without fail every day. Okay, and I hope Bharani sir has given you all the other details on when the session is there and when it is not. And for any updates, please ask your colleagues or fellow faculty members to join the Telegram group. We've already posted this on all your mail IDs. Please check your mails. And for any updates, please check the Telegram group. Thank you, Mr. Bharani. Please take over and carry on with the. I just don't
Thank you.
want to waste any more time. Thank you so
Yep,
much.
yep. Thank you.
Thanks,
Thank you so
everyone.
much, Ms. Shiva. Okay. So let's continue. I'll repeat. Yep, Ms. Sudharani. Since it's the first day, yeah, certain glitches would be there. Um, and from tomorrow, I'm certain that we will not face those issues because this is a new software, Webinar Jam, which can accommodate a lot of audience, and it has a lot of cool questions, opportunities to be explored. Yeah, thank you. Thank you so much, Ms. Shiva. We'll proceed further. And once again, faculty members, welcome, and we will ensure that there is no glitch. Okay. So machine learning on cloud and auto ML is going to be the future. And when it comes to auto ML, people who are going to pursue their career as data scientists, and if they are going to work in industries and companies, they need not know how to write even a single line of code. Python, R, Scala, Spark, Java, whatever. They need not know how to write even a single line of code. Trust me when I say that. I'm going to show you hands on in tomorrow's session or from tomorrow's session onwards, and you will love it. And people need not even know how the algorithm works behind the scenes. That means even if they have zero knowledge about the math behind the scenes, they can still solve business problems. And that is the promise of AutoML. Already major players from Amazon, that is, Amazon SageMaker, which is AutoML, or I would say, which is machine learning service of Amazon. Then Microsoft Azure and Google Cloud Platform. These are the players who are disrupting the way machine learning algorithms are built. And these are the players who are disrupting the way people see data science as a profession. Google Cloud Platform, GCP. That's the abbreviation. Okay. So I was saying that 90% of the students or the people who aspire to become data scientists, they would like to go and join companies such as Infosys, TCS, Microsoft, Google, Amazon, etc. And they want to work as data scientists over there. And roughly 10% of the students would like to pursue the field of research, where they want to do active research. They want to pursue their PhD or postdoctorate and then come up with new algorithms, new trends, new disruptive innovations. For them, for this segment of people, they need to know core programming. They need to know core math, applied mathematics, because they have chosen to do something which needs that knowledge. But for the remaining 90% of the data scientists, do they need to actually know each line of code? Do they need to know each equation in math derivations? Not really. And for that, I just gave an example. I would repeat that because a few of y'all were saying I wasn't audible. Okay, so let me tell you that if TCS, for example, wins a bid, wins a project from, say, ICICI Bank. Say ICICI Bank wants TCS to build a loan default prediction model, meaning who are the people who will take the loan or not and not repay the loan. So loan default prediction model is what ICICI Bank wants TCS to build. Then ICICI Bank would be least bothered on whether people in TCS are writing one line of code or 10 lines of code. Are they using Python or are they using R? Or are they using Scala? Which programming language are they using? Right? So they would be least bothered about all that. All they would be interested in is, did you solve my business problem or not? Which is building loan default prediction model. Simple. And if TCS is able to accomplish this, job done. So the people who are going to work with TCS would not write the program right from scratch. They would not derive a new algorithm and then start using it. Instead, they will either reuse the code which is already available with them, because every organization has something called as OPA, organizational process assets. Each and every project which TCS does in the space of data science or anything, they record it and store it for future purpose, for future use. So whenever there is a new project which TCS gets, the data science team working in TCS will go and search for similar kind of projects in TCS's OPA. They will see whether TCS has already done such projects in the past or not. If they have done, they will try to get that data, they will try to take that code and they'll try to reuse that. This is one way of accomplishing. And that is exactly what is happening even now in the industry. Having said that, there is this new breed which is coming up called as auto ML and machine learning on cloud. This auto ML and machine learning on cloud does not even require you to write a single line of code. You need not even worry about the previous projects which that company has done in the past. That's how powerful it is, and this is going to be the future. Already organizations have started using it big time. So it's high time that we understand the aspirations of the students and tailor the training according to the needs. If someone wants to go and work with a company, we cannot force them to learn each and every equation, each and every derivation. Doesn't suit them. People say horses for courses. You need to use the right horse to win a race, right? And we need to churn out students who are industry ready or who are research ready. And this auto ML is for these people. These set of 90% students who want to go ahead and become data scientists. But if you are pursuing the field of research or PhD or postdoctorate, yeah, you need to know in-depth programming and in-depth math. And you need to know about how the algorithms are built, and you need to know all the finer nuances of the algorithms. Because you, as part of your research, might be writing new programming languages, or you might come up with new algorithms, so you need to know that. Okay, having said that, let's move on and understand more. There is something called as artificial general intelligence. And this is the intelligence of machines that can understand and automatically learn any type of work or activity that a human being can do. This is the ultimate goal of AI research. And we'll talk more about this on the last day of the session. I'll get to the agenda, but before we get there, a lot of people, that I've interacted with in the past are confused on what are these terms: artificial intelligence, data science, machine learning, deep learning. They do not have good understanding on these terms. They misinterpret or they interchangeably use these terms. So let us first demystify this part. What is artificial intelligence in the first place? We are humans, right? And we have some intelligence. That's called as what? Human intelligence. Human intelligence. Using human intelligence, what do you do if you drive a car? Say you're driving a car. What do? You control the steering, and then you maybe apply brakes as need be, and you change gears, so on and so forth. Human is doing all these things. Can I automate this? Can I bring this human intelligence artificially into a machine or into a robot or into a computer or into a system? If I can do that, that is called as artificial intelligence. So automating human intelligence is called as artificial intelligence. And now for this particular example, we have SDCs, self-driving cars or autonomous vehicles, right? So what these vehicles do, like Tesla, etc., they will automatically control the steering. They will automatically apply the brakes. and they will automatically apply the gear or change the gears. So the human intelligence is automated, and that's called as artificial intelligence. How do you accomplish this? You can accomplish this using data science. Data science, or any science, when you work on this stream, you'll be called as a scientist. And people who are working on data will be called as data scientists. You do some research, right, to build AI applications. And data science is a culmination or combination of statistical analysis, data visualization, forecasting, and so on and so forth. Within data science, there is a subset which is called as data mining. And data mining is like coal mining. What do you do in coal mining? You dig coal and you get coal. Here you dig data, you dig into the data. And when you dig into data, you get insights from the data. You get information from the data. And sometimes when you dig coal, you might get diamonds. And that is very precious. Similar to that, when you dig into data, you'll get insights which are as precious as diamonds. And that is what organizations need. And any data science training should cover all these aspects, which will help you get the insights which are similar to diamond. Okay, and within data mining, you have various branches, such as supervised learning, which is also called as predictive modeling. You build your predictive models, predictive modeling. And then there is another stream called as unsupervised learning. And then you have another branch called as reinforcement learning. These are the various streams which exist within data mining. And usually people call supervised learning and unsupervised learning as also machine learning, which is a field within data mining. Within data mining, there is a field called as machine learning. And here is where you learn about machine learning algorithms. These machine learning algorithms could either be supervised or unsupervised or reinforcement learning. Within machine learning, there is a subset called as deep learning. And deep learning is synonymous to neural network nowadays. When you say deep learning, it's nothing but neural networks. And you have a lot of algorithms such as artificial neural network, convolution neural network, recurrent neural network, LSTMs, GRUs, transformers, BERT, GPTs, sequence to sequence models, you name it. Right? And then there are autoencoders, GANs, bunch of those, RBMs, DBNs, all that. Okay. And then there is this new stream which is coming up, which is called as reinforcement learning. Okay, so these are a few things that you need to understand. And then you have business intelligence. This is another thing which people keep asking me. Hey, what is the difference between a data analyst and a data scientist? Okay, if this is the present date time, whatever happened in the past, if you take the data until 1 second before, if you take the entire data and then analyze this past data and generate certain reports on that, that's called as business intelligence. And this is accomplished using data analyst. Okay, data analyst usually does that. For example, if you have COVID-19 cases, how many COVID-19 cases do we have? Do we have until now in India? In each of the states, how many COVID-19 cases do we have? Right? In each of the districts, how many do we have? How many of them have recovered? How many of them got inoculated with vaccines? So on and so forth. Talking about the past data is the role of a data analyst. And whatever happens in the future, that is, how many COVID-19 cases will we get in the next 2 months? How many COVID-19 cases would we get in each of the states of India in the next 2 months, etc.? These kind of questions which you're addressing are related to future, and these are accomplished by data scientists. Okay, but typically a data scientist is a person who also understands everything about data analyst role, right? Data analyst does certain activities, data scientist does all of that. On top of that, data scientists will help you predict the future. Okay, that's the way world is moving. And you'll have data engineers, yet another rule. Data engineers are the people who establish pipelines. For example, hey, we have the data in Excel in a specific server, or we have the data in a database, maybe Oracle database. How do we pull the data into, for example, Python? How do we ensure that this code is written in such a way that whenever there is new data, the algorithm will automatically run? Then, how do you take this data and build your machine learning algorithm? Once your algorithm is built, which most likely than not will be some equation, some math equation, how do you deploy that in production? What do you use? Would you use a web application, or would you use a mobile application? Or which application do you actually use to deploy your model? Right? So establishing end-to-end connections, connecting all these varied softwares is the role of a data engineer. So typically, you have data analyst, data scientist, and data engineer. Of course, there are a lot of other roles. We will get to it later. But broadly, just remember these things. And you know what? All these three things are automated using AutoML. Wow. So now organizations are thinking about how much will it cost us to use AutoML services versus how much would it cost us to hire data analysts or data scientists or data engineers? Yeah, so sure, this session is getting recorded, my dear friends, by the way, and we are placing it on our YouTube channel. I'll towards the end share the link of our YouTube channel. You might want to just subscribe to it so that you're notified as and how these sessions are uploaded. Don't worry. We understand that there'll be poor network connection at a few of your ends, so we'll counter that. That's a workaround. Okay. So reporting about the past is BI. Predicting the future is your machine learning. Data science is all about creating that future and exploring all the future opportunities and leveraging that is the role of AI. Okay. Now, why do we need AI for better decision making? For these purposes. Number one, We can do away from we can move away from broadcasting to personalized decisions. What do you mean by that? Say I have HSBC Bank, and say I have 40 million customers, and I want to do marketing. I want to send a marketing email to my customers. And what is that email? If you buy the new iPhone, you get, say, 20% discount if you use HSBC credit cards. If you use HSBC credit cards, you get 20% discount on the new iPhone. Then, would you send this email to all the 40 million customers? If you're going to send to all the 40 million customers, that is called as broadcasting. I will send it to everyone. Whoever is interested, they will use it. But the flip side is, if you start doing that, people, the moment they see emails related to HSBC, they will ignore. They will send too many emails, too many discount emails, ignore them. Or even worse, they will select your email and click on unsubscribe. Or they might click on spam. All that risk you have. But then AI will help you move away from this and take the route of personalized decisions. How? These 40 million customers can be grouped, and you can group related customers together. Maybe all the political, folks in one cluster. Maybe all the student community in one cluster. Maybe all the bridge customers in one cluster, so on and so forth. And then look at which segment or which cluster, which group of related customers would like 20% discount. Okay, that would help you send out emails only to the focused group, and that will help you avoid death by average. It's called as on an average, people will like it, is your assumption. But AI says, no, that's wrong. Let's do personalized decision making. Okay, then batch processing versus real-time processing. Gone are the days where you say that, you know what, let me collect all the loan applications. Whoever has applied for the loan for the day, let me take all that applications and let me process it once in a day. Gone are those days. That's called as batch processing. Now the new norm is real-time processing. The moment someone applies for a loan, immediately process that. And AI will help you get from here to here. And it will help you avoid death by delay. Reactive versus proactive. Hey, we are working on machine. If this machine fails, I will send my technician who will go and fix the issue. That's reactive. Proactive is, even before my equipment, manufacturing equipment or machine fails, I'm going to send my technician to proactively fix that issue. And the moment you go to proactive zone, you know why the machine might fail. Right? So it will help, AI will help you avoid death by ignorance. Next, you have tactical versus strategic decision making. AI will help you move from tactical to strategic decision making. Tactical means, hey, machine failed, so what do I do now? Okay, switch off the machine for 1 hour and then switch it on. Tactical, you're just trying to fix that issue for that moment. But AI will help you move towards strategic decision making. Hey, all of our machines have certain equipment. There is a pattern that those components are likely to fail. So we'll have to probably replace all of that for the long run. So it will help you, AI will help you avoid death by nearsightedness. Okay, next. Here is the agenda, friends. Towards the end, we will take your attendance, and those of you who have given your attendance would be receiving the certificate, right? So if you're not attending, you might not get. So please bear that in mind. So first session will be on auto ML, and in this auto ML, some amount of programming I will do, and do not worry too much. It will be only little bit of programming, and we will do this on Google Colab. Even if you don't have a good computer, better configuration computer, don't worry. We'll make use of the free service of Google Colab and run the code. Then we will move into AWS, and then we will be exploring Amazon SageMaker. SageMaker is a machine learning service within AWS, and we'll be exploring Autopilot, which is auto ML functionality. Then there are certain other machine learning services, and we will be exploring Amazon Lex. And Amazon Lex is used to build chatbots. Okay, we will build this also hands-on. All these are hands-on services. And to a great extent, we will ensure that we make use of the free services which exist. And then we will switch to Microsoft Azure. And this is actually 4, my bad. And this is 5, and this is 6. Okay. Microsoft Azure. And we will be exploring Azure ML Studio, Machine Learning Studio. And we will explore the drag and drop functionality. Then we will switch to Google Cloud Platform. We will here make use of GCP's auto ML capability, and we will see how they have introduced this capability. And finally, we'll wind it up with state-of-the-art algorithms nowadays. When you deploy the algorithm, people expect you to bring in the explainability aspects. We'll also talk about this, and that would conclude our training. Okay, this will be spread across 1.5 hours each day. All right, so stay focused, and trust me, this is going to be a big revolution, auto ML and machine learning on cloud. Today, I believe we'll not have time to do hands-on, but from tomorrow onwards, we will have hands-on. We will do hands-on. Okay. So welcome to the world of automated machine learning, friends. And do you know what? Whenever you work on any project, the first thing that you need to do is you need to learn project management methodology. And there is a methodology called as CRISP DM. But I would say that you have to start exploring something called as CRISP MLQ. ML stands for machine learning. Q stands for quality assurance. Okay, and what is the difference between these two methodologies, and why CRISP MLQ is more relevant to your machine learning projects is something that we'll quickly discuss briefly at a high level. Yeah. So, step 1, you need to understand what is the business problem that you're trying to solve. Step number 2, you need to understand what data you already have and what data you need to go and collect. Third, you need to understand what are the various data pre-processing techniques or data cleansing or data preparation techniques. Once you have the data prepared, you have to supply the data to your models. And there are specific models which expect you to supply the data in a specific format. Only then they work. Once you build your model, it is not foolproof yet, right? You need to evaluate, you need to check whether the model that you built is actually working well or not. Is it giving you the desired accuracy or not? These are a few things that you need to understand. Suppose that you deploy your model in production. Your CRISP DM stops here, but your CRISP MLQ says that you take this discussion a little further to understand not just the deployment, but also start looking at model monitoring and maintenance. Very, very important, friends. Model monitoring and maintenance. Okay, what do you mean by that? Let me briefly help you understand. Okay. Typically, what happens is data science team has bunch of people who will understand the problem, who will pre-process the data, who will select what are the important features. They take help of subject matter expert. They build the right model. They tweak the hyperparameters to ensure that they build the best model possible. They review the outcomes, so on and so forth. But the part which CRISP MLQ specifically talks is about model monitoring and maintenance, which is post-deployment activities. Post-deployment. For example, say in your data set, while you were building your data, or while you were pre-processing or as part of your data collection, say you found a variable called as income. There was a column or variable called as income, which you were using in your model building. And when you looked at the probability distribution of income, say it was appearing like this. If you have data like this, it is called as exponential distribution. Forget what is exponential distribution, etc., friends. Don't worry too much. Say this belongs to some distribution called as exponential distribution. That means there'll be very less number of people with very high income, and a lot of people belong to middle income group and low income group. That's how income as a variable would be, right? You have only a few Ambanis, a few Tatas, right, who are very rich, and majority of them belong to middle income group and low income group. So that's called as exponential distribution if the plot is like this. And you built your model on this data, say on various columns, but this was one of the columns. And then you deployed your model. Deployment can happen on mobile application or a web application, or it could happen on your enterprise applications. Wherever it is deployed, doesn't matter. So after deployment, if you leave your model, if you say that, okay, I deployed the model, my job is done, then you might run into risk wherein your model might work for some time. It might give good results for some time or for a few months. Suppose that maybe it starts degrading when it comes to the accuracy. Maybe in the initial days, accuracy of your model was 97%, but over a period of 3 months, maybe it dropped to 94%. Maybe over a period of another 3 months, it dropped to 89%. If you're not monitoring your model, you really don't know how to update and when to update your model. And CRISP MLQ says that post deployment, you need to monitor your model for something called as data drift. What do you mean by data drift? Data drift means earlier income was following exponential distribution, But over a period of 3 to 4 months, maybe income started following normal distribution. It's a change in the distribution itself. You built your model when income was exponential, but over a period of time, the distribution changed to normal. So your model will no longer start giving you the good accuracy it was giving in the past. Such data drift happening in your data should be monitored by the data scientists. Now the question is, will the data scientists who are paid very high salary work on new projects, or will they start monitoring the old projects? What should they do? They're paid high salaries. Until unless they work on new projects, it's not going to be beneficial for the organizations who have hired them for such high salaries. But at the same time, if the old projects are not monitored, if the data drift happens, customers will start complaining. Customer will say, hey, you guys are very clever. When you deployed the model, you ensured that a model gave high accuracy. Now see what's happening after 6 months. There is a significant drop in accuracy. Now this is $1 million question. What should companies do? What should the performing organizations, meaning companies such as TCS, Infosys, HCL, Wipro, Accenture, Deloitte, etc., who does consulting, do? They cannot afford to keep their data scientists on old projects monitoring. So people came up with AutoML. All these phases, right from data collection to data preparation to model building to evaluation to deployment to post-deployment monitoring, everything is performed automatically, especially when it comes to the cloud service providers such as Amazon, Microsoft, and Google. Of course, you have IBM, Oracle, Ali Cloud, etc., but these three are the big players. Okay, so it is an iterative process where the data scientist also must ensure that data drift, model drift, etc. are addressed. Okay, here is the new breed, okay, and the new way of looking at your projects. All right. To perform automated machine learning, there are a bunch of things which exist. You can perform hyperparameter optimization. You can perform NAS, neural architecture search. It will automatically search your architecture. Should I have 3 hidden layers or should I have 2 hidden layers? Should I have 3 neurons or 1 neuron in each of the layer? How should I build this architecture? What are the hyperparameters that I need to choose? Right, so it's a huge task. I'll prove you guys on how challenging that would be. And automated feature engineering. One simple feature engineering is, say you want to predict, whichever variable you want to predict is usually represented using Y, capital Y. Say you want to predict whether your vehicle will break down or not. Okay, whether it will break down or not. And say one of the inputs was time of purchase. Another input was time of failure. Say your vehicle failed. Third variable was latitude, and fourth variable was longitude or longitude, however you want to pronounce that. Now the question is, the moment I have these inputs, should I use these inputs as is in my model, or should I do some feature engineering with that? Yeah, what do you think, friends? If I give you these two variables, latitude and longitude, do you think you should use these two to build your model? Or do you think we should not use these two for model building? Let me quickly put a poll question here and I'll let you guys answer this. So, poll question coming your way. Should we use X3 and X4 as is in predicting Y, or okay, let me put this, that's it, predicting Y. Yes or a no? Here goes your question, and let me again show this. Yep. Please go ahead, friends. Please answer to that poll question. Interesting. 50-50. Please answer to that poll question, friends. On your mobile also you can, right? Or on your desktop will be even more easier. 70%, 60%, 66% of them say yes. 70% of 72% of y'all say yes, 69% of y'all say yes. Interesting. Okay, that's fine. So let me tell you that you should not use these two as is, friends. You have to do some feature engineering. And what should you do? Use these two and come up with a new variable. And what would that new variable be? If you know latitude and longitude, you can understand location. Right? You can come up with location. And if you know location, you can also know whether it is hilly area, is it a desert, which location did your vehicle fail? If you know these things, how will it help? Maybe, some engine fluid liquid is getting hard because it's very cold area. Or maybe your engine is getting heated beyond a point because it is desert and summer season. Who knows? How do you know whether it is summer season or winter season or any other season? You can look at time of failure, at what time, what date. From that, you can know the season, summer season, winter season, rainy season, etc. That information coupled with location information would give you new features which will be more meaningful in classifying whether your vehicle will break down or not. And this is what is called as feature engineering. What if this is automated? Wow. What if this is automated? What if this domain knowledge is brought into your model building? Yeah, that's an extreme experiment of auto ML, which organizations have already started doing for life sciences, healthcare, etc. They have already started doing such things. Now the question is, oh, does this mean end of data scientists? No, that's a myth. Does this mean data scientists will no longer exist because everything is being automated? Not really, that's a myth. Here, building a machine learning algorithm has many other activities to be performed. like understanding the business properly, understanding where the data is, in which format the data is. Do we actually have the data needed to solve a problem or not? Or do we need to get more data? Where do I get it from? Do I need to perform a survey? Or do I need to perform an experiment? Or do I need to perform simulation? What do I do to get the data? Once I get the data, from there on, automation begins. So the routine mundane activities which data scientists typically perform, that portion is automated. That portion where your IQ level is still needed is not automated. And in the near future, at least for a decade, the way researchers predict, it won't be automated. Okay. So at least for 1 decade, you have a very good future for data scientists. And even to use auto ML applications, you need people with the knowledge about all the algorithms. At least at a high level, you need to know. Okay. Another myth. Okay, that means you know what? Only the routine tasks which are of low complexity would be automated. No, friends. Do you know what? Understanding your neural architecture and which architecture to be used is by no means a toy problem to be solved. Understanding which hyperparameters to be tweaked is by no means a toy problem. So a lot of routine but advanced options which data scientists experiment with is being automated using automated ML. So do not assume that only the small stuff is automated. Yeah. And if you want to know what are the bunch of open source platforms and tools which are available, here we go. From Microsoft, you have NNI, which is, I would say, amazing when it comes to automating. And NNI stands for Neural Network Intelligence. Neural Network Intelligence. Then you have Auto Scikit-learn. sklearn is a Python library for machine learning, and you can use that. You have AutoVeca. Veca stands for Waikato Environment for Knowledge Analysis. It's an open source machine library. And then you have AutoKeras, which is Keras is a deep learning library, which is now an integral part. Keras is now an integral part of TensorFlow 2.0. And then you have Teapot. We will do a hands-on on this. This is an amazing automated ML tool. You will start loving it. Tree-based pipeline optimization tool. Then you have Ludwig, you have AutoGluon, which is from AWS Labs. Then you have Feature Tools, which is a Python framework, H2O, PyCaret, so on and so forth. There are a bunch of these which are available. And there are also commercial tools which are available, which are more popular, I would say. Out of all these things, I would rate this as number one when it comes to the market share. Then you have Azure Automated ML, and then you have Google Cloud Auto ML. Then you have Data Robot, H2O, Driverless AI, and obviously AI. These are a few other commercial tools. A few of them work on freemium model. What do you mean by freemium? A few of the options are free. For using a few other advanced options, you need to pay. That's how it works. Now, I'll stop here for today. And tomorrow when we connect, we will quickly discuss Teapot, and then we'll get into the hands-on portion of it. Then we will do hands-on one day on Amazon SageMaker Autopilot. We will take a use case and solve it. We will understand Azure Automated ML, and we will do a hands-on on this also. And then we will understand Google Cloud Auto ML, and we will do hands-on on this as well. So tomorrow, please ensure that you're there in front of your system, and then all these sessions are recorded, and we are placing these sessions on our YouTube channel, link to which has been posted here on your screen. If you see, there's a YouTube channel, and it will also be posted on Facebook and LinkedIn. So whichever forum you feel is wise, go ahead with that. If you're finding difficulty in finding our YouTube channel, just go to 360digitmg.com. The moment you scroll down, you'll have a link here. That's our YouTube channel. So go here to our YouTube channel and just click on subscribe. And you know what? This is a free live session which is happening. If you have difficulties connecting on your webinar jam, please connect on our YouTube live. Okay, either way it works. Okay, we will be sharing with you all a feedback link now in the chat window, or we would rather share attendance link. Feedback will take on the last day, Venkatesh Perlu. So, please give your attendance. We'll be sharing that link to give attendance, and then you can give your attendance. People who attend all these sessions, obviously you'll get a certificate of participation. All right, friends, I will stop here. Thank you so much, and we will connect again tomorrow and take this discussion forward. Thank you all, and bye for now. Yeah, if you have any questions, you can just post it on the chat window, and I'll be more than happy to take your questions. In the interim, while the session was on, we were anyways, I was looking at your questions, and then I was answering your questions. There we go. Attendance link is given in the sticky note. I will also request our team to post it on our YouTube live on the chat, so that you can people who are attending via YouTube live can also give your attendance. Okay, we posted that on a sticky note, friends. Let me quickly show you where it is. Here it is. It'll be there in the sticky note here. Let me, here, sticky note. Okay, that's a sticky note. And also our attendance link is posted on our YouTube live. You can also give your attendance there. Thank you once again. See you all tomorrow, and we will do hands-on from tomorrow. Thank you.